Okay, so we have a lot to cover today, so I'll try and go a little bit quicker. So pause if you need to. We'll do a little warm up here. Find the area and perimeter of the following. So when we look at this shape, perimeter, again, is the distance around the outside. Problem is I don't know this dimension. So what I can do is I can make a little triangle right here, drag that off to the side, and I can fill in some missing pieces of information. So I know the height here is 8. I'm going to call this S for slant height. It's on an angle. And then I just have to know what this bottom dimension is. Well, the bottom is 14 and the top is 10. That leaves me a difference of 4. And then because I have these little tick marks here showing these are the same length on each side, I know that I can make this a 2 and a 2, and if I draw this down, this is what this shape would break down to. So 2, 10, and 2, that's a total of 14. And this is a right triangle, so I can do a quick Pythagorean theorem. That's the hypotenuse, leg squared plus leg squared. So I would have the hypotenuse squared equals 4 plus 64. This would be 68, and then I would take the square root of both sides, and I would get a slant height of, the square root of 68 is 68 square root 8.2, we'll say. Okay, hopefully that's visible. So that's 8.2. So I know this side now is 8.2. This side is 8.2. So when I do the perimeter, I would have 8.2 plus 10 plus 8.2 plus 14. Remember, those are all the outside dimensions. I am not including that one. That is a dimension that's inside the shape, so we do not include it. We only deal with the outside dimensions. And if we added all of those up, we should get a nice value of 40. Sound about right? 16, 40.4. Sounds right. Okay. Now that's the perimeter. You'll notice you had to do one little Pythagorean theorem to actually solve that problem. And now let's go after the area. This is a trapezoid, and we have a nice little formula that saves us some time. And we happen to know all the dimensions, so that makes it really easy. Okay, so I have area equals 10 plus 14 all over 2 times 8. And so the area of this shape, 10 plus 14 is 24, divided by 2 is 12. 12 times 8 is 96. So this would be 96 meters squared. Cool. Okay, so there's your warm-up. Today we're going to jump into composite shapes, and this is combined shapes, so more than one shape combined together, and we're going to use that to find the area and perimeter. So we'll start off with something a little straightforward. Find the area that is shaded in yellow. Okay, so now there's a couple ways to do this. You could chop this up and have 4 rectangles. That would be one way you could do this problem. You could chop it up, determine the area of each one of those rectangles, and add them up. That would be completely acceptable. So if you looked at the area on the top one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a 15 by 3. So the area here of this top shape here would be 45 squared. 9. This one here is 9 by 3. Okay, and you can see this starts to take a little while. So that would be 27. There would be another one on the other side is 27, and another one on the bottom of 45. And if you added all of those up, you would get a total area of 45 plus 45 plus 27 plus 27, that should be 144 square units, whatever they might be. So that's one option, okay, but that might not be our most efficient option. Okay, so now an alternate way to look at the problem is something like this. could we take a giant yellow square that's filled in? So this is 15 times 15, which is 225. And what if we subtracted the area that was in the inside, which is 9 times 9, which is 81. Okay, so if we have 225 minus 81, we get the 144 square units we got by doing all the small pieces. Okay, so either way is correct. You still get the same answer, but one of them's a bit more efficient. Okay, so with composite shapes, more than one traditional shape combined, we can add or subtract areas to determine the desired amount. So let's just take a look at that. We can add or subtract. That's important. Okay, so here's a weird looking shape. For the following square, that's important, find the area of the yellow shading. The missing piece is half a circle. Okay, so if we were to look at this picture, I would probably draw this as a square minus a half a circle. Okay, so that's in my mind what I'm going to try and do. So I'm trying to figure out what all of this, okay, and then I'm going to subtract this from it. So if I looked at this square, I'm going to tick these all off as being the same length. So the area of this square is 12 squared, or 144 centimeters squared. Now the circle I have to approach a little bit differently, because the area of a circle is pi r squared. But I don't want the full circle. What I want is half the circle. So I'm going to take the original formula, the pi r squared, and I'm going to divide it by 2, and then I'm going to make a little note here that this is just half. Okay, because I don't want to confuse myself that I'm using the incorrect formula. So this is half of this circle. So now the only dimension we need is the radius. Well, if you look here, we know this is 12, okay, and that goes from edge to edge and through the center of the circle, so that happens to be our diameter, which means our radius would be half of that, or just 6. So I can come back here and I can say the area of my half circle would be pi times 6 squared all over 2. Okay, so that would be 3.14 times 36 divided by 2, so 56.5. Okay, and now again, I want to make sure I am subtracting. I'm not going to add these two together. So my area that's shaded, that says shaded, even though it's all blurred together, would be 144 minus 56.5. And that should be 87.5 centimeters squared. Okay, so we can add or subtract those values. Okay, so Maddie is designing a logo in its graphics arts class. How can Maddie calculate the area of the blue section? Okay, so pause it here if you want to take a shot at this and try it on your own. There's a few little tricky parts to it. But you can probably see where this solution is going to go. Okay, so when I look at this, I see the area of the big circle minus the area of the little circle twice. So that's what my brain is thinking. That's how I'm going to, so if I can find the area of the big circle and then minus 2 of the little areas, I should have my answer. So let's just move this guy, over here for a second, and so we're going to need 2 of them. Oops, get out of there. So we need the dimensions. Now this is the trickiest part of this question, is finding the proper dimensions, partly because of the way they drew the dimensions on here. Okay, so if you look at this dimension up here, this 3 centimeters, okay, drawing the arrow to the side is fine, but you can also draw the arrow this way. Okay, and then I could also draw it this way. And this this circle down below is the exact same. So now what you can see is I have several of those 3 centimeter radiuses all working together. So when we look at this dimension right here, which is the radius of the big circle, we can see that is 6 centimeters. So this is 6 centimeters. For the small circle, the radius is 3 centimeters. So if we wanted to do this in one line, or very few lines, it would look something like this. The area of the shaded equals the area of big minus 2 area of littles. Okay, and then here's how I would continue with that thought. I would say pi r squared, for the big is a 6 squared, minus 2 pi r squared of the little, which is a 3. And then I would let my calculator do the work. Okay, so this becomes 36 pi. This would become 3 squared is 9 times 2 is 18. This becomes 18 pi. And you could punch all of that in your calculator if you want a little more sophisticated approach. Because these are both measured with pi, we can treat that kind of like collecting like terms. So 36 pi's minus 18 pi's leaves me with 18 pi's. Or we can multiply that together and get 56.5 centimeters squared. Cool. Okay, so quick summary. Things you need to know. It's all listed there. I'll let you read that at your leisure. So you can break down and build up shapes. That's an important idea. There's a couple of pictures here for other ones, but just pause it and take a read of that. Oops, jump forward. Okay, and then our last one, find the perimeter of the following object. So remember, perimeter is the distance around the outside. I don't care about this dashed line on the inside, it's not important. So when you're looking at the perimeter here, there are 4 pieces to making up this perimeter. Okay, because these have single ticks, these are all 8s. So getting these 3 here is pretty easy. So we have 3 8s, and then this is the key. We have a half circle we have to figure out. And that's the only thinking part in this problem. So if we add up our 3 8s, there's the 24. Now we have to figure out what half a circle is. Okay, well, the expression for circumference or perimeter of circle, we can do this either as 2 pi r or pi d. We'll go 2 pi r. But that's the expression for a full circle. I don't want a full circle, I want half of it. So I'm going to divide all of that by 2. Okay, so that's me making a decision that that's half a circle. Okay, so now if I put in the information I have, the 2's are going to cancel nicely. I'm going to be left with pi. And now I just have to determine the radius of that circle. So if it's 8 from here to here, that means my radius is 4. So if I put a 4 in there, I can calculate my perimeter now as 24 plus pi times 4 should be about 36.6 centimeters. And notice it's single centimeters, it's not square units. Okay, so there's a couple to try. Thanks for tuning in.